Now let's have a code walkthrough to the solution. Let's create a function merge sort that will sort the given array. Let's pass the lower bound and the upper bound, the lower index and the max index. So we're gonna find out the middle element, right? Middle point M. So we check if the lower bound L is less than upper bound U, we calculate the middle point by finding the exact mid, which is L plus U divided by 2, or we can write it as L plus U minus 1 divided by 2 for avoiding overflow for large values of L and U. With this middle point, we break the array into two halves and sort them recursively. So first merge sort for the one partition and the second for the other partition. First partition will start from the lower bound till the midpoint, and the second merge sort is for m plus 1 till the upper bound. And then we will merge these partitions. So here we will pass all the arguments and let's create this function. So here inside this we need to create two temp arrays, left and right. The left will be the one of size m minus l plus 1. So temp left and right arrays we're gonna create here. So first is n1, which is the left one, and it is of size m minus l plus 1. And now the right one, n2, it is of size u minus m. Okay, now we're going to copy the data to these two arrays. So for x in range 0 to n1, we will add l plus x the element from the array to the left array. Similarly, we add elements after the middle point to the right array. So let's do this. Let's copy the data for x in range 0 to n1. Left x, and this is l plus x, and here let's fill the data in the right array. So y, and here we will say m plus 1 plus y. So this will fill up the left and the right subarray. Now we have to merge them, and you know that how we're gonna do the merger. For that we will take I equals to 0, the initial index of the first array, and j equals to 0 for the second subarray, right? And k for the merged array that will start from L. So these are the three pointers that we're gonna use. Now we're gonna take a loop where I will go till n1, which is the bound for the left subarray, and j will go till n2, which is the bound for the right subarray. So these are the two pointers. Now we're gonna put elements into the solution array from these subarrays, left and right, one after the other. We're gonna check if the element in the left is less than the right, then we will increment the I, right? Because we're gonna select the element from the left subarray. So we are putting the element by taking it from the left, and we're putting it at ARRK and incrementing the I. Else, we're gonna select the element from the right subarray. So ARRK is right I and right j, and this time we will increment j as we've selected the value from the right subarray. And then after this we will increment the k, as this is for the merged subarray, which will increment each time as we are placing the values in this array. And after this, if there are still elements left in these arrays, we will copy them. So if there are elements present in the left subarray, take them and put them in the solution array and increment I. And we'll do same for the right subarray. So while j is less than n2, ark equals to write j and increment the j and increment the k. So this is the complete implementation. Now let's call this implementation by passing an array to this merge sort method. So let's create an array arr and let's pass 11, 6, 3, 9, 14, 66 and 2. And now let's get the length of this array, len arr, and let's invoke merge sort by passing all the parameters. Let's pass array, let's pass 0, which is the lower index, and n-1, which is the last index of this array. Now let's take a for loop to print all the elements after this sorting. Print the arri, that's it. So now let's save it and let's run this. So let's run merge sort. So this is the sorted order of all elements present in this array. And this is how merge sort works.